Greetings and welcome back to Pluralsight. My name is Bruce Mackenzie Lowe and you are watching Advanced Troubleshooting Techniques for Windows Server. In this module, we'll talk about troubleshooting system lockups. I'll show you what to do when your system locks up and how to go about analyzing the hang in the debugger. More specifically, I'm going to show you why Windows servers hang, and you'll see they hang for a variety of reasons. I'll then show you how to go about troubleshooting them. We'll then talk about how to go about forcing memory dumps. Up till now, Windows has crashed on its own, but with a hang, you must manually intervene to force a crash so you can subsequently analyze it with the debugger. We'll then cover a couple crash dump analysis, namely a stop 80, which is an NMI hardware failure, so someone forced a crash on a hung system, and then we'll go ahead and talk about another one. They are indeed completely different. We'll finally finish up with a summary of what you've learned. As you may know, system lockups are one of the most challenging outages to resolve. In this section, I'll talk about why Windows servers hang and give you some troubleshooting tips along the way. The top reasons for system lockups include primarily depleted system resources. This includes available RAM or memory pools or page file space. Some system resource has become depleted, and as a result the system has locked up. It more or less is a cascading effect where threads lock up and they lock other things, and pretty soon the whole system locks up. Another reason for system hangs is a driver spin lock. This is where processors are trying to acquire the same spin lock, and the processor that owns the spin lock is off doing something else. You can then hang a system with kernel mode deadlocks. As you may know, when a thread owns a resource that other threads want, this provides a deadlock scenario, and if the thread that owns the resource is off doing something else, well, this can cause the whole system to hang. Another reason for a system lockup is when you have these runaway, high-priority, compute-bound threads. This will essentially monopolize the system so no one else can get any time, and the system is perceived to have hung. Finally, you can get non-responsive device drivers or faulty devices that'll cause the system to hang. So as you can see, there's a variety of reasons why a system lockup may occur. To assist you in determining what part of the system is locked up, here's a handy little chart to go over the degrees of unresponsiveness. As you see on the left-hand side, a total freeze would be up towards the top, and a partial freeze would be towards the bottom. So if you in fact have a total freeze with a hardware failure, a good test you might want to do is tapping on your num and caps. That'll show you if the LEDs are lighting up on the keyboard. If it truly is a hardware failure, you won't get any kind of response. Now, if you believe that the hang is in the operating system, a good test to do there is a Control-Alt-Delete to see if you can get the attention of the operating system. This way you can discern whether it's a true hardware failure or whether it's in the operating system where the hang is occurring. Now, as we get less and less frozen, so to speak, a partial freeze, maybe it's just in the CSRSS or the GUI that's freezing. A test that you might want to do there to determine that is just move your cursor about to see if it's responsive. If your mouse moves, then it's not a GUI freeze. There's other conditions that may cause a partial lockup, such as an OS thrashing condition. Here, you might want to use the task manager to see if there's some runaway threads out there, or maybe spin locks or deadlocks or low memory conditions, such as a SRV 2019 event or a 2020 event. A disk I/O freeze can also occur, and you'd want to use perhaps the disk management tool or Explorer to check out to see if any disk drives are non-responsive. A network freeze, a little bit different. There's several things you could do to check to see if your TCP/IP stack is functional or not, and that would be just to ping the loopback or a local gateway. How about the workstation service? You might try connecting outbound to remote shares, or the server service, you might try connecting inbound to shares. Finally, an application freeze, you'd again want to use the task manager to identify any high CPU time for various processes. So hopefully this chart gives you a good idea of how to isolate the hang as to what part of the system it's occurring in. Here's the main three things you'll want to do when you're troubleshooting system lockups. First, you'll want to manually force a memory dump. Up until now, the operating system has crashed automatically whenever it encountered a condition or a fault. Now, this time when the system locks up, you're going to need to manually intervene and force a memory dump. The next thing you'll want to do when the system reboots is to collect system and application logs. You want to get all the information to troubleshoot the issue before maybe the logs get cleared or purged or something to that effect. Finally, you'll want to save the system configuration information with a tool such as MSInfo32. This will capture all the various device drivers and system components so you know what was present on the system at the time of the hang. Now, when you force a memory dump, you'll get one of two types of blue screens, depending on what mechanism you use to force the crash. With servers, you will typically see a Stop 80 bug check or an NMI hardware failure. This is when someone uses the physical NMI button or a virtual NMI button via a remote diagnostic tool. Now, with desktops and laptops, you're more likely to see a Stop E2 bug check, which is a manually initiated crash. This requires a keystroke combination to cause the server to crash, which I'll show you in a subsequent section. When you start analyzing your system lockups, I want to provide you with a few useful debugger commands to keep in mind. To start with, you'll always want to check for any deadlocks or spin locks that may have caused the hang. To do that, you'll start out with a bang analyze-v-hang, which will check for any blocking locks. Another command to keep in mind is the bang locks command, which will show you any locks that are held by various threads. Finally, there's a bang qlocks command that will show you the ownership of any spin locks. Next thing you'll want to do is check for any interesting threads. You can look at the current thread at the time of the crash with just the bang thread command. You can use the bang running-it command to see which threads are running on the different CPUs. Finally, you can use the bang stacks command to display all the different threads out there and what they're currently running. Another good debugger command to check out the memory utilization is bang VM. This will show you the virtual memory utilization, the available RAM, page file space, memory pools, etc. You can also look at the physical memory utilization with the bang mem usage command. Finally, if you do suspect a memory issue, you'll want to check out the memory pool consumers. You could do so with the bang pool used 3 to look at non-paged pool, and also the bang pool used 5 to look at the paged pool.